deep ocean mineral resources and the law of the sea. This is the presentation. And as Subrantu told before that I am the former director of the National Center for Polar and Ocean Research in Goa. And I have been associated with the deep ocean mineral resources as well as the UNCLOS for almost 15, 20 years in different capacities. So now, can we go into the next slide, please? This is the only time I'll tell about that, Yeah. So this is the outline of the person. What am I going to do today? I'll start off saying that where does the land territory of a coastal state end? Where does our coastal state end, and where do the oceans take over from there? So the boundary between the land and the oceans, and what are the kind of non-living resources that one can expect on the seabed and subseabed beyond national jurisdictions. So I'll be basically concentrating on the deep sea resources. When I say deep sea, it's not the depth alone. It is the resources which go beyond the national jurisdiction of a country. And now the question is that who owns these resources? It is in the international waters. Who can explore and exploit these resources? Have you got any guideline in place which will govern the sustainable management of the resource? Or is it a free fall? Anybody can go ahead and do exploration, exploitation of the resources, and who is responsible for the fragile ecosystem of the deep ocean? That's also very critical. And are there any rules available right now? And all the rules which are available, are they adequate enough? Are they maintainable? If they are not adequate enough, what are the options we have got before us? Now the million-dollar question: when and where and how the mining will take place. We all know that there's a lot of exploratory activity in the deep ocean, but a stage is likely to come very soon when there will be the first step which will be taken by some country or some consortium or some entity to take up the mining of the deep ocean resources. When it will happen, where it will happen, how it will happen, or if at all will it happen, that's the big question which I will try to answer. And what are the lessons we have learned so far from all our knowledge base so far? Yep. So this will be the outline of my presentation. I'll go through each one by one. I'll start off with the first one is that I will start off with something about the UNCLOS, the law of the sea. What exactly does the law of the sea mean? Can we have the next slide, please? Okay.
It is struck actually.
It's stuck there? Okay.
Yeah.
Anyway, I'll continue talking. The basic thing is that UNCLOS, or United Nations Convention of the Law of the Sea, 1984, it is the first attempt by all the nations to put together a set of rules in place to govern the ocean space. See, when it comes to the land territory, we always have some rule, national legislations are in place. Within the 200 nautical miles of a coastal state, we have got national legislation which will govern what we can do. We will talk about the territorial rights, and which talks about the marine scientific research, which talks about,
Dr. Rajan, sorry to interrupt. I think Dr. Sahu, will you please try to see? Yeah, it's coming now.
Yeah, now it's there, right? Now it is there.
Yeah, it's moving, yeah.
Okay, so we'll start with that again. 1982 Convention on the Law of the Sea, it entered into force on 16th November 1994, and India ratified the convention immediately. India was among the first countries to ratify the UNCLOS in 1995. So basically, what does the convention say? The convention considers a lot of articles, 320 articles, 17 parts and other things. But of primary concern to us geoscientists are the convention deals with setting the limits and the responsibilities of the coastal nations. It deals with the maritime zones, which I have highlighted in yellow. It deals with deep seabed exploration and deep seabed mining. And it also deals with the protection of the marine environment. It deals with scientific research in this area, marine domain. And settlement of disputes, of course, as a geoscientist, we don't come into the picture, although my field of expertise happens to be dealing with the settlement of disputes. Okay, going to the next one, so primarily what happens is that it's called a regime for the oceans because it seeks to codify the ocean space into several maritime zones. The important thing about this codification is that the sovereignty of the coastal states or the coastal nations, they extend for specific distance offshore. And as you go offshore from the land towards the deep ocean, the sovereign rights of the coastal states are being phased down through successive zones, in the sense that the sovereign rights you have got near shore is not the same as what when you happen to go about 200 nautical miles offshore or 400 miles offshore, or when you go into deep ocean floor, your sovereign rights get diluted. And again, most important thing is that beyond the national jurisdiction, about which I will be talking about, it declares the high seas and the sea floor. The sea floor is known as the area, and the waters above are known as the high seas, which are outside the zones of national jurisdiction. They have been declared as the common heritage of mankind. So beyond national jurisdiction, anything and everything belongs to the whole humanity as itself. So it's not to be shared, but there are some rules which allow us to do exploration and exploitation. That's what I'll be discussing about in the course of my next few slides. Yeah. So this is the schematic of the maritime zones. I'm sure all of you know about it. And it's actually a slice of the ocean. If you start from the land on the left side to the deep ocean floor on the right side, we have got a gently sloping continental shelf, which goes into a slightly steeper dipping continental slope. Then you've got a continental rise, which is actually where most of the sediments get deposited. And beyond that, we have got abyssal plains. So this area itself has divided into separate maritime zones up to a distance of 12 nautical miles from the baseline. Baseline is nothing but it's almost coincides with the lowest low water level. And then we have got up to a distance of about 24 nautical miles, we have got a contiguous zone, which is nothing but a buffer zone between territorial sea and exclusive economic zone. The exclusive economic zone is the area, as the name itself suggests, it gives sovereign rights to a coastal state for the water column as well as seabed and subseabed resources. Then beyond 200, we have got a new terminology called the extended continental shelf beyond 200 nautical miles. These are contained in certain articles of UNCLOS. I'm not touching much about that, excepting to say that if a coastal state can prove that it has got a continental shelf which extends beyond the exclusive economy, beyond 200 nautical miles, then it can lay claims to the extended continental shelf. But the caveat here is that although it has got the extended continental shelf, it cannot make claims to the water column above. Now we go to the next one. What are the potential deep sea mineral resources which you get beyond national jurisdiction? So there are a whole lot of suite of mineral deposits we know about, starting from the land. If you go deep offshore, what are the kind of mineral deposits we will get? Can we just show the next slide, please? Yeah, here we go. See, on the right side, you have got the land, and the left side, you have got a deep ocean floor. We have got nearshore deposits of sand and gravel, as you all know, the placer deposits, the phosphorites near the shelf slope area. We have got the gas hydrates and hydrocarbons in the continental slope, rise areas. And then you have got abyssal plains, which have got three kinds of mineral deposits or resources. The so-called polymetallic nodules. On the seamounts, you have got a cobalt-rich ferromanganese crust, and in the spreading centers, you have got a polymetallic hydrothermal sulfide mineralization. So what you see within the oval, polymetallic sulfide, cobalt-rich crust, and manganese nodules these are the three mineral resources about which I'll be discussing more rather than on the land, because these are the deposits which are usually occurring beyond national jurisdictions. I say usually occurring because there are some exceptions. In some cases, there have been reported occurrences of cobalt-rich crust or hydrothermal deposits which occur very close to the exclusive economic zone of a coastal country, especially in the northern and northwestern part of the Pacific Ocean, the Pacific Islands. I'll deal with that aspect also. So going to the next slide. Yeah. Here we have got the three kinds of deposits, the resources, if I may. We have got hydrothermal sulfide, we have got the cobalt-rich crust, and the manganese nodules. What you see here, the white dots all across the mid-Atlantic ridge, mid-ocean ridges, mid-Atlantic, it goes all the way around. They are the polymetallic sulfide deposit hydrothermal in spreading centers. So in a spreading center, you can expect
the questions will be asked after the lecture.
You can stop me at any time. I know if it's
Yes,
I would say let's make it more informal so that So anybody who is who has any doubt or any clarification or thing, you're free to ask me any questions. Stop me at any stage. I'll be glad to share my answers.
Rajan sir, excuse me, Rajan sir. That question answer we'll have at the end of your talk.
Okay, no problem. I leave it to you people. Whatever you decide, it's fairly good enough with me.
Please continue uninterrupted.
Okay, sure. Thank you. Thank you very much. So now we have got this spreading centers. What you see in the white dots here are spreading centers. The mid-Atlantic ridge on the eastern side, this goes all around. And then you have got East Pacific, right, in the Pacific Ocean. And then in one part of it goes all the way down south of Australia and ends up in the Indian Ocean. We have got the Southwest Indian Ridge, Southeast Indian Ridge, the triple junction, the famous Roderick triple junction, before it goes northward into Carlsberg Ridge on the western side and goes to the Red Sea. So along all these mid-Atlantic ridge, mid-ocean ridges, you can expect hydrothermal sulfide metallics. Apart from that, there are also certain areas on the northern and northwestern part of Pacific Ocean where you can expect in the back arc basins, and you also get a lot of occurrences of hydrothermal deposits, hydrothermal occurrences, I would say. And then we have got the ferromanganese crust, which you see hashed, the yellow colored one. Wherever you have got a sea mounts, you expect a kind of a ferromanganese nodules. I would call them as ferromanganese crust, but there are some nodules also available in this area. And then you have got the famous polymetallic nodules. What you see, the most important occurrence of polymetallic nodules is what is written as in the central part of it. You can see the blue one, the hashed one, Clarion Clipperton zone. That's the area between Hawaii on the northwestern part and Mexico on the southeastern part. That's where you have got a lot of interest. And then south of India, in the Central Indian Ocean Basin, where India has laid its claim for exploration, we have got the polymetallic nodules. So these are the three kinds of mineral resources for the deep ocean. As you can see, most of these occurrences are beyond the national jurisdictions. Okay, the next one, please. Yes. So I'll be touching each one of them. I'll be discussing each one of these resources, and I will also discuss about how the law of the sea views these deposits and how we take it up from here. Can we go to the next slide, please? I don't know whether you see the slide moving or...
It is probably stuck up, sir.
Yeah, that's what, No, it's okay. So I can go on talking till you get the next slide. So basically what we see here are the three kinds of deposits. So these three kinds of deposits which fall outside the national jurisdictions. Basically, I mean, the common sense logic tells us that, look here, there's nobody to stop us from going and exploring for these resources. But the problem is that if it is a free for all, it's always the developed nations which will have the prerogative. They have the resources, they will be able to go. So now, thank you. So we'll start with the polymetallic nodules in the modern ocean basin. So now there's something which I'm sure every geoscientist must have read or seen or even touched in nodule. The nodules are nothing but what you see down below are these seabed nodules. It's like an apron spread across the seabed. The spherical congregations or the kidney-shaped structures, they comprise primarily of iron and manganese oxides and hydroxides that contain economically valuable concentration of cobalt, nickel, etc. In addition to trace amounts of molybdenum, platinum, and other base metals. So that's what makes them important. They have certain valuable concentration of essential elements. The nodule accumulations of economic interest occur primarily in the Clarion-Clipperton fracture zone, which I mentioned about you. You can see in the center of the first slide at the top, Clarion-Clipperton zone between Hawaii and Mexico, the oval-shaped one, as well as the Penryn and Peru basin, which you can see I've circled them. The Peru basin to the west of Peru, obviously, and the Penryn basin, which is occurring in the western part of the Pacific Ocean. And the interesting thing about the Penryn basin is that most of these occurrences of polymetallic nodules fall very close to the exclusive economic zone of some of these island states. So what it says is that within the exclusive economic zone, potentially beyond, the manganese nodule deposits are found in the Cook Islands, the islands of Kiribati, the island nations of Tuvalu, Niue, Cook Islands. So these are certain island states which have got an access to these resources. So I go to the next one is the seafloor hydrothermal systems along mid-ocean ridges. Which I showed you before that, you have got along the mid-ocean ridges, you have got seafloor hydrothermal activity. Going to the next, this is almost something which I'm sure every geologist must be. It basically tells that seawater, cold seawater goes down. What you can see on the right side is the arrow which is going down. It is the cold seawater percolates down along the fractures of the mid-ocean spreading centers. As it goes down, the water gets heated up. High temperature, very high pressures. It leaches over the material from the host rock. And finally, at a temperature of about 400 degrees Celsius and other thing, it becomes buoyant, and then it starts going up. It starts a return journey, laden with a lot of elements and minerals. And finally, at the top of the spreading center, it spews out in the form of hydrothermal vents. And it builds up what is called the precipitation chimney, made up of basically sulfides. So what happens is that it's called a black smoker or white smoker, depending upon the kind of the minerals which constitute. The black smoker basically relates to iron sulfide or manganese sulfide, whereas at a very lower temperature we get a sort of silicates, barytes and silicates built up. A smoker is something but a chimney which is built up, and material which spews out and which is on the flanks of the spreading centers. You have got a metalliferous sediment. So this is of interest because many of the sulfide deposits are rich in base metals. So when they're rich in base metals, naturally there's a temptation for everyone, and they occur in diverse geological environments, in diverse tectonic settings, as I told you before. We have got the red dots, which is along the mid-Atlantic ridge, East Pacific rise, Pacific and Arctic ridge, Southeast Inner Ridge, Central Inner Ridge, Southwest Inner Ridge, and finally after Red Sea. The red dots are the proven occurrences of hydrothermal mineralization. And what you see, the yellow dots are unconfirmed, but they are still there. And then you have got a backhand spreading center in the western part of the Pacific Ocean, Kermadec, Laoar, Tonga, New Hebrides, Mariana Trench, and other things. All these places where you can expect in the back arc areas also, we have got several active venting areas. Then we have got the intraplate volcano sitting bang in the middle of the ocean, just like, we have got the famous Loihi seamount in the central part of the map, which I show southeast of Hawaii. You have got a red triangle marked. That's where you have got another location or locus of hydrothermal mineralization. That happens when you have got an island going across or a plate going across a hot spot and leaves its trace there. So there are three ways where there are tectonic settings wherein you can expect these hydrothermal mineralization in the form of mid-ocean ridges, back arc spreading centers, or intraplate volcanic and other activities. The next one, please. Yeah, this again sums up the same thing. Three ways where you can expect. We can have a mid-ocean ridges on the left side, back arc basin on the right side to top. Mid-ocean ridges or back arc basin, it can either be sediment hosted if it is mixed with sediment, metallogenic sediments, or it can be also volcanic hosted if they are occurring on the top of the actual axis of the spreading centers. And we have got a back arc basin, and then we have got the seamounts where you can be either axial or off axis. So different geological environments and different tectonic settings where you can expect hydrothermal mineralization. Yeah. The next one, please. Yeah. Coming now to the kind of minerals you can expect it. As I said, basically they're primarily comprising of sulfides, iron sulfide, zinc sulfide, copper sulfide, silicates occasionally depending upon the temperature again, lead sulfide. And there is a subtle variation between the back arc hydrothermal deposits and those you will get it across the mid-ocean rich deposits. This one tends to be much more rich in chalcopyrite and other things, as well as in silver, gold, palladium, and platinum, whereas the back arc deposits have got a richer concentration of native metals. And these deposits are marked by high concentration of base metals, particularly copper and iron, which constitute more than about 48%. That's what makes them interesting. And trace element contents like cobalt up to 0.248% and arsenic less than 1%. And zinc content is generally very low in this. Yeah. So, yeah, now we go into cobalt-rich ferromanganese crust. This is a new one. Actually, basically, if you look at it, they are nothing but manganese nodules. They are similar in composition to nodules, but the only difference is that the cobalt content constitutes about 2%, which is richer than. So, what it means is that a manganese nodule, which has got a higher concentration of cobalt encrustation, we tend to call them as cobalt-rich ferromanganese. What you can see down below the picture, which shows a slice across a ferromanganese crust. The crystal portion, what you see in the dark brownish one, the thin veneer of brownish color, is cobalt-rich. And then again, you get it. Most of them occur again on the western part of Pacific Ocean, southeast of Japan, as well as of Peru. And of India also, we have got in the Afnaski Nikitin sea mounts, where the deposit or where occurrences of cobalt-rich ferromanganese crust have been identified. We have not started exploring those things, but yes, there has been some interest in exploring for cobalt-rich ferromanganese crust on the sea mounts southeast of India, as well as in the Pacific Ocean, as well as in Peru. So they occur at depths of about 1,000 to 3,000 meters as coatings of encrustation, which is what I said before. Mostly they occur around island states in the Pacific and especially in the prime zone of Japan. So that's where you get most of this cobalt-rich. The important thing about cobalt-rich crust is that it is likely to be the most commonly occurring deep seabed mineral sources. The main reason is that they occur closer to the land as opposed to a manganese nodule, which is in the abyssal plains. So the nearness to the land is one of the reasons why cobalt crust is of interest. Now, from there, I go to the next one. Who does these deposits belong to? These resources, whom do they belong to? And is there any agency which can guide and control these exploration of these resources? I'm sorry about that. Yeah. So now I'll go into a bit of the legal part of it, in accordance with the UNCLOS, basically, as I said before at the beginning, it is seabed and the ocean floor and subsea bed beyond national jurisdiction as well as its resources. That's what I have highlighted, are the common heritage of mankind. And the exploration and exploitation shall be carried out for the mankind. So when you do exploration and exploitation, it's not exclusively for your country. We have to do for the benefit of the mankind as a whole on behalf of a global authority. It's an intergovernmental authority which has been established under the UN Convention on the Law of the Sea, International Seabed Area, Seabed Authority, known as ISA. This authority has been established with a responsibility to encourage, develop, and promote prospecting, exploration, and exploitation. So they are the agency which will not only guide exploration, but will also promote exploration, and that also acts as a kind of a watchdog for exploration and exploitation, because the most important thing is that we are dealing with a very, very fragile environment. Somebody has to be very careful when you go ahead and explore the deep ocean resources. Yeah, the next one, please. So the authority is also mandated, this is what I said before, the authority is also mandated to ensure effective protection of the marine environment from harmful effects. So whatever you do, whether you are doing for exploration or whether you are doing for exploitation or any seabed related activity, we are disturbing the ecosystem there. So the ecosystem disturbance also has to be, we have to be very careful about it. So any party can start prospecting, provided the activities in accordance with the law of the sea convention and with the regulations are up. So you can go ahead and prospect. But when it comes to exploration, there are some guidelines in place. You cannot go and explore an area without the knowledge and without a kind of a concurrence from the United Nations Convention on Law of the Sea, as well as authority which has been mandated to look after the prospecting, exploration, exploitation. Yeah. So what has happened is that 3 regulations are in place already. For each of these mineral resources, we have got a regulation in place, which is adopted by all the countries. There are about 165 countries which are signatory to the United Nations Convention on Law of the Sea of these things. They have got this regulation for polymetallic nodules. How can you go ahead and explore polymetallic nodules? I'm talking about in the exploration. It's not exploitation per se. When you come to exploration of polymetallic nodules in this area, the beyond national jurisdiction, there are sort of rules in place. How can we do that? Who can do that? It has to be an entity. It has to be sponsored by an entity by a country. And the country is responsible ultimately. The guidelines are in place. We have to not only explore it, we have to put it in the public domain. We have to go ahead and then plus also we have to develop capacity building, transfer of technology between the country which is exploring as well as the less fortunate one or the developing nation. So there has to be a kind of a handshaking between the countries or the entities which do the exploration and the countries who don't have the kind of equipment, the facilities, or the core competence to take up this exploration. Then there's a regulation for polymetallic sulfide and regulation for cobalt crust also. So as you can see, one has been adopted in 2010, and the cobalt crust is fairly new. It has been adopted only 2012. Yeah. So now that the regulations are in place, as on date, the International Seabed Authority has entered into 31 15-year contracts, 22 contracts. By contract, I mean any country or an entity which has been sponsored by some country. Because some countries, they don't go flying their own flag. They go through an entity, a separate organization, like for instance, China goes through something called a COMRA, or there can be an organization which will be responsible for the exploration, but it will be basically sponsored by a country. 22 contractors for the exploration of polymetallic nodules. 19 contracts have already been signed for the exploration of which 17 are in the Clarion Clipperton Zone, leaving only 2 in the Indian Ocean. I'll come to that again. Polymetallic sulfide, we have got 7 contracts have already been signed, and cobalt-rich manganese crust, 5 contracts have been signed. The areas being explored are the Clarion Clipperton Zone, primarily for polymetallic nodules, the Indian Ocean for polymetallic nodules and hydrothermals, Mid-Atlantic ridge for polymetallic nodules as well as hydrothermal, South Atlantic Ocean for polymetallic nodules, and the Pacific Ocean for cobalt crust as well as the polymetallic sulfides. So we got 31 contracts. So that means we are developing a database. The know-how, knowledge base is being gradually built up about exploration. We know much more about the deep sea resources now than we knew about 10 years back. Because when you have got 31 countries going ahead and doing the exploration, definitely the outcome is going to be a better knowledge base. These are the exploration of the minerals in this area. As I said, what you see in the Clarion Clipperton Zone, you can see a whole lot of countries are already there. Belgium, Korea, France, Bulgaria, Czechoslovakia, Czech Republic, I mean Poland, Russian, Slovakia, Kiribati, and several of the Pacific Island states. But then in Georgia, got the government of Poland, government of Russian, you see the difference. These are sponsored by the government themselves, whereas Nauru, Singapore, Tonga, UK, and other things by separate entities. We have got in the Indian Ocean, we have got the government of India sponsored polymetallic nodule exploration in the Indian Ocean, which you see the square there. And then we have got in the Indian Ocean again, Southeast Indian ridge, we have got the government of India, Germany, government of Korea, and China also. So 4 parties are exploring for polymetallic sulfides in the Indian Ocean sector. And then in the Northwest Pacific, you have got again China, COMRA, as well as Beijing, government of Korea, Japan, and the Russian Federation involved in the exploration of cobalt crust as well as hydrothermal minerals. So 31 contracts, and people are already there. And now I will come to a couple of things which will be of interest to the community at large. When you have when you sign a contract with International Seabed Authority. For polymetallic nodule, for instance, the exploration area, they allocate the exploration area to us based on our request. Okay, we will say that this is the area we would like to do the exploration now. And the area is allotted to each contractor cannot exceed 150,000 square kilometers. So that's the bottom line. You can explore less than that. But the maximum area which is given to a contractor for exploration over 15 years is 150,000 square kilometers. But the caveat here is that of which the contractor is expected to relinquish 50% of the area of equal commercial value in 3 phases. 20% first, 10% first, and 20%. So at the end of third year of signing the contract, you have to relinquish 20% of the area. At the end of the 5th year, you have to relinquish 10% of the area. At the end of the 8th year, you have to leave 20% of the area. This area which you are relinquishing to the International Seabed Authority, it forms a part of the reserved area for the humanity as a whole. So the thing is that we are proving that there are deposits there or there are resources in this area, 50% of the area. And this area, which is kept as a reserve, is for the benefit of the developing nations. Because that is where we are entering into a bit of a delicate situation. When it comes to polymetallic sulfides, hydrothermal sulfides also, the exploration area is only 10,000 square kilometers. It comprises of different blocks, 100 blocks, blah, blah. And again, here is that at the end of the 8th year, almost 75% of the total area has to be relinquished, leaving the contract with only 2,500. So although we start with the 10,000 square kilometers, at the end of the 10th year of the contract, you will be left with only 2,500 square kilometers. The remaining 7,500 square kilometers of area, which are relinquishing to the International Seabed Authority, forms a part of the reserved area, which is for the benefit of the humanity at large. Same thing goes for cobalt-rich crust also. The maximum area is only 3,000 square kilometers, of which no block should be greater than 20 square kilometers. So these are the caveats which are in place when it comes to applying for an exploration license. Now, focusing more on the Indian Ocean sector, what you see here are the 4 countries which already laid claim for exploration. What you see in the central part of it, the northern part of it, just west of 90 Strait, what you see, the one in pink and yellow color, are the areas which have been given to India for carrying out exploration of polymetallic nodules, of which the yellow one is the reserve area of 75,000 square kilometers, which have already relinquished to International Seabed Authority. And the what is in pink is the 75,000 square kilometers area, which we are retaining for exploration and possible exploitation by India. Coming to the polymetallic sulfide, hydrothermal sulfide, starting from the southwestern part of the bottommost part of it, you see that almost the pinkish color one. It is the area which has been locked at 10,000 square kilometers area on the southwestern ridge, which has been got to China. And then when you come towards the Rodrigues Triple Junction, and what you see is something in slightly pink color is the area which has been given to India, southwestern ridge, as well as a part of the central ridge. And what you see on the right side, the red color one, is the what area which has been given to Germany for taking up the exploration. And then further north, we have got the area 10,000 square kilometers which has given to Korea. So 5 countries are already there which are doing the exploration for polymetallic nodules as well as polymetallic sulfides. Yeah, then next one, please. So yeah, see, now I'll touch upon what India has been doing as far as the PMN program is concerned. I'm sure, geology, GSI has been on the forefront when it came to polymetallic nodule exploration program, right from the time, at that time, we had a veteran, Dr. Siddiqui, sitting at NIO, and we had veterans like Dr. D.K. Saha, Srivastava Saab, Malik Saab, just about everybody who started marine wing in GSI, based in Calcutta. So together, there was a good handshaking and then a seamless transition or transference of knowledge from one side to another, which led to the exploration activities for polymetallic nodules in Central Indian Ocean Basin. It started in 1981 on board RV Glavashni. And the first nodule samples are recovered on 26th of January 1981 from the equatorial Indian Ocean. And India was the first country to file her claim with the Preparatory Commission for the International Seabed Authority, seeking exploration license for an area of 150,000 square kilometers, which is what you see, the entire area, which you see in different colors, is the area which has been originally given to India for exploration. The total estimated oil resource in the reserved area is about 365 million square kilometers. And in 1987 rather, India was registered as a pioneer investor and allocated an area of 150,000 square kilometers. And we have moved further forward. We have identified the first generation mindset with equal commercial grade, as I said, copper plus nickel plus cobalt and abundance of nodules. Of this equal commercial grade, as I said, half has to be given to International Seabed Authority. So we have relinquished under the contract agreement area of 75,000 square kilometers and relinquished in India in phases, leaving an area of 75,000 square kilometers. That's what you see in the white color. The white polygon, whatever is contained within the white polygon is the area which is retained by India. And what you see in the purple color, the green color, and the brown color are the small areas which has been relinquished by India to International Seabed Authority as reserved area. So that is where it stands now, and India has gone ahead. And now coming to the next one, where again India is waving its flag across, is that hydrothermal exploration program. We started our exploration program way back in 1983. Primarily, we were concentrating on the Carlsberg Ridge area, mostly because it was closer to us, and then we were having access to the area. And to an extent, we are also working in Southeast Indian Ridge. And in 2012-13, we started a major preliminary multi-institutional, multidisciplinary initiative in parts of Southwest and Central Indian Ocean. What you see, that's a rectangular area north of Roderick's Triple Junction, RTJ, is the area we started doing preliminary investigations. It's not on a mission mode over the period of about 6 to 8 months, where I'm happy to inform you that JSA was a major partner along with the Ministry of Earth Sciences. And based on the results of the preliminary surveys, as well as the information which is available in the public domain, we submitted for an area of about 10,000 square kilometers and 100 blocks, etc. We submitted to the International Seabed Authority seeking the exploration license, and it was done by the Ministry of Earth Sciences in April 2013, following the regulation which you discussed before. And we also gave them an approval, seeking an approval for a plan of work for the exploration in this area. Yeah, the next one, please. So one thing led to another, and on the 26th of September 2016, the Ministry on behalf of the Government of India, we have entered into a 15-year contract with the International Seabed Authority for the exploration of polymetallic sulfides in the Indian Ocean Ridge. The details are available in the International Seabed Authority website. So now we come to the next question. We have been making a lot of noise. All the countries have been saying that just about a decade back also, that by 2020, 5% of the world's minerals, including cobalt, copper, and zinc, could come from the ocean floor. That has been a statement which has been going around, And however, as of today, barring oil and natural gas, and just about it, I would say only barring natural gas and oil, seabed exploitation of many other resources remain woefully inadequate. We have not reached that golden threshold of achieving 5% of the world's mineral, including copper, and zinc, from the ocean floor. What could be the reason for this one? Number one, uncertainty. Uncertainty of the resource. We really don't see searching for a mineral resource at a water depth of about 2 kilometers and beyond in uncharted waters is like searching for, even searching for a needle in a haystack, the common analogy which is given. I would say that's also easy. Unless, I'm sure most of you who have been sailing, you know how difficult it is to locate a resource or even a hydrothermal vent in this area. Second thing is that scientific and technological challenges, exploration, exploitation, depends on several factors. Distance of occurrence of the land, the oceanic depth at the site, and especially. So if the area is close, the occurrence is close to the land, there will be more interest. The farther away it is from the land, the deeper it occurs, and the smaller is the extent, the interest of the country to go ahead and explore will be less compared to a deposit which is closer to the land, at shallower depth, and is large, extent is large. And the cost economics and the demand. Unless there's a demand for a critical resource, which is scarce on land and available in the ocean, the cost economics is very prohibitive. It's not easy to go ahead and charter a ship and go across and mine an area. And the present scientific technological know-how for exploration, feature development, and exploitation. See, we have got a certain technological know-how. We have got certain technological know-how for exploitation. And just a while back, Dr. Ray was mentioning about what the Minister of Earth Sciences mentioned about India is developing its own manned submersible. It is happening. It's happening in south of in Chennai, the National Institute of Ocean Technology, and plus Minister of Earth Sciences also come up with a mission plan, a deep sea mission plan for the next 15 years or so, wherein exploration for these deposits is going to be one of the prime things. So excepting for oil and natural gas, so I would say for exploration and exploitation technology for oil and natural gas, I would say that fairly is very well developed. I mean, we can definitely, there's a scope for improvement for exploration and exploitation technology, but compared to what we have got for hydrothermal sulfides on nodules and crust, the technology is currently adequate. And when it comes to hydrothermal sulfides, nodules and crust, I told you we have got about already 31 exploratory contracts. So when you have got more contracts, more nations are going ahead and exploring for these resources, the technology is definitely going to leapfrog into the next decade. And I'm sure that very soon we are going to have adequate technology for the exploration of the mineral resources on the extended continental shelf as well as the deep oceans. Yeah. So there are challenges, there are scientific, but nothing has held back commercial prospecting exploitation. The most critical thing which is hampering the development and sustainable utilization of the mineral resources of the deep sea bed relates to the fragile marine environment. A whole lot of things can affect the environment. And how are you going to circumvent these anybody's guess? The impacts associated with the presence of ships and machinery in the surface. I mean, in the land itself, we know the difficulties, but when you are taking ships across, the machinery sitting on the seabed, and we are also dealing with noise and air pollution, fluid leaks and discharges from the vessel and equipment. And there's also conflict over stakeholders. The fishermen also will be affected. Impacts to the water column, disturbance to the marine life by life. Because these are the organisms which are living in waters so pristine. So we can't go ahead and just disturb them. Whatever you are doing in the ocean or marine environment is going to have an impact on the water column. So environmental impact is perhaps the most critical element which we have to keep in mind when it comes to talking about the mineral exploration and exploitation. The next one, please. So there's a whole lot of impact to the seabed and subseabed. I'm not read through the whole thing. It's an introduction, light in the seafloor, increased noise, pollution, damage to the nodules, destruction of the wind community, mortality of the species, sediment plumes, loss of biodiversity. So just about so many things can happen. And whenever you happen, all these things are going to affect the environment. So these are not things which are going to be recovered soon. So you disturb the environment, you can't leave it there for 10 years or 15 years and say that, look here, it will recoup by itself. It's not that easy because it's so fragile. So unless you see that area, the deep sea, but you will not realize that it's like seeing a penguin in the polar regions. They're so friendly. They know they really don't. They're not meant to human beings for long. So the way they react, unlike an animal in our country or any country for that matter, how it reacts when it's a human being. They are not used to this one. They are not used to any incursions onto the environment. Yeah. The next one, please. Having said that, I go into another uncharted area, deep sea mining. Is it going to happen? How is it going to happen? 3 questions: how, where, and when, if at all. So the cartoon or the schematic which I show on the right side is the schematic is showing the process involved in deep sea mining. for the three mineral resources which I was talking about, hydrothermal sulfides on the first one, which is occurring on the spreading centers and everything. You need a lot of machinery there. See, in all cases, what you need is you need a platform from where you can do the dredging or where you can do the drilling, any operation. And then you have to have a transportation vessel which has transported people, machinery across for thousands of kilometers. That's another thing. And we need to have pipes, we need to have return water. So we need to have a whole lot of machinery. So the kind of machinery which you need for exploration and exploitation of hydrothermal vent is different from what you need for a polymetallic knowledge, which occurs at a depth of 4,000, 6,000 meters. And finally, when you have got a cobalt-rich crust, we are talking about 800, 2,500 meters. Yes. Okay. So now the question is that where are you expecting the resources? And I mean, we know where the resources are. Where are you going to expect exploitation, if at all? So there should be some critical area where people might already be thinking about exploitation. It's the northwestern part of the Pacific Ocean. What you see here are all these dots are the sites which have been explored for polymetallic sulfides, hydrothermal vents, cobalt-rich crust, or polymetallic nodules. So what is interesting about this area is that you have got a lot of islands scattered here. You have got a Cook Island, Kiribati, Samoa, Tuvalu, Nauru, Micronesia, Melanesia, Marshall Island, Cook Island. See, one or two. So you have got a whole lot of islands sitting next to where we have got the mineral resources. So naturally, see, the caveat which I said before is that if you have got something which is sitting next to you, you'll be tempted to explore and exploit these resources. So that's what actually these Pacific Island states would like to do. They would go ahead and not only explore it, but they're also planning to exploit these resources. But the question is that can they do it? There is a clause there in UNCLOS which says that the reserved area, basically the reserved area is for the developing nations, and these are developing nations. So they get the priority in exploration and exploitation. However, the caveat again, I mean, the problem these nations face is that they don't have the kind of technology to do it. So because they have the resources nearby and they don't have the technology, what they do is that they do it by proxy. So what they do is that many of these island nations have sponsored mining companies to take out license on their behalf for PM and exploration possible mining. For instance, Tonga has sponsored Tonga Offshore Mining Limited, Nauru has sponsored Nauru Ocean Resources, Kiribati has sponsored Marawa Research Exploration. They're all subsidiaries of Canada-based typically. So this is the interesting thing. We have got a whole lot of organizations, we have got a lot of countries, and we have got sea companies which are doing the exploration and exploitation on behalf of these Pacific Island states. So now that the interesting question is that, see, by another 2 years from now, the exploration license of all these countries would have expired. So what happens, supposing they covered and say that, look here, we know where the resources are. We want to go ahead and exploit these resources. That's exactly what the Nauru's president declared on the 25th of June 2021, about 5 months back. He said that he notified International Seabed Authority of the intention Nauru. He said that Nauru is going to apply for approval of mining in 2 years in the Clay zone. And he asked the International Seabed Authority to complete the adoption of rules, regulation, procedure required to facilitate approval of the plan of work. See, I told you that we have got rules in place for exploration. When it comes to exploitation, International Seabed Authority is said to come up with the rules and regulations. But you have got this catch, there's a 2-year rule. The 2-year rule is very clear. If a coastal state or any country is prepared to go ahead and do the mining, and if the International Seabed Authority is not in a position to come with the guidelines, then the country is free to go ahead and exploit the resources. The catch here is that countries are assets. We have not adopted the regulations. We are still arguing and discussing about it. There's no code in place for extractive mining. And the International Seabed Authority was supposed to meet in 2020, but as you know that the gathering was postponed due to the pandemic. It has not met so far. So still, there are draft guidelines in place. It has been circulated for the information for the concurrence of the people. But unless and until all these all these countries meet together, discuss and finalize the extractive mining technology and mining protocol, we will not be able to allow anything. Plus, the important thing is there are several environmental groups, Greenpeace, the EU Parliament, several Pacific nations. We have all called for a moratorium on deep sea mining. They argue that we know very little about its impact. So when you don't know anything about the impact of what will happen to the deep sea, when you have got exploitation of the resources, why should you go ahead? Why not we have a moratorium on deep sea mining until such a time we are sure about its impact? And recently, about 3 months back, about more than 350 scientists from 44 countries signed a petition calling for a moratorium on seabed mining until sufficient and robust scientific information has been obtained. So it's almost like a catch-22 situation. There are countries that are prepared to go ahead and do the mining, but there are several people who are against this. And this is something which came in the news in October, on 29th of October 2021, just about 10 days back. New deep sea mining rules set to miss the 2023. The 2023 deadline is put forward by Nauru, saying that June 2023, if the rules are not in place, we are going ahead and will start exploitation. But the Latin American and Caribbean countries are saying that it's just not, doesn't appear feasible right now. But have we got any? See, I would say there's an incident which happened. It happened in 2007. A Canadian mining company by name Nautilus Minerals, they deployed a submersible. They went to the north in the Bismarck Sea, of northern part of Papua New Guinea, entered an agreement with Papua New Guinea, and said that, look here, we are going ahead and explore and exploit the metal hydrothermal vents. Because it's available there, we are going to go and mine. Because it happens in the exclusive economic zone and now Papua New Guinea, with their own national legislation is good enough. And in the years that followed, the company drilled and drilled and drilled. And by 2090, Nautilus went bankrupt. And the Papua New Guinea government, which had resigned actually, which had invested in the project, was left with millions of dollars in debt. So there's a moral here. See, you cannot go ahead and do it until and unless the environmental group is ready, until and all the countries are prepared, and we all know the risks involved, and we know there's a cost economics worked out, and we know what is in it for all of us. Okay, the next one. So that's the moral of the story. In conclusion, I would say the major non-living resource of the deep ocean floor beyond national jurisdiction could be polymetallic nodules, cobalt, ferromanganese crust, hydrothermal sulfide deposits, gas cylinders, and hydrocarbons also could come in. The resource potential of most of the coastal states will be, so most of them, they fall outside national jurisdiction. So the coastal states per se, they don't have a resource potential or the strength to this one. Because commercial floor mining has not been successfully carried out, and because scientific modalities are just emerging, it's difficult to predict the future of the business. We don't know which direction it's going to go. Whether mining is possible, Where we know where it can happen, but will it happen? It's anybody's guess, because there are so many challenges faced by both the legals, for the geoscientists at large, the environmental lobby. So there's a whole lot of people who argue for and against this. Next one, please. So resource exploration, exploitation can seriously impact the seabed, the water column, and the biota. So that's critical. Unless until there's a way out, the bottom line is that we cannot do the exploitation. We can explore, basically, if we have some guidelines in place, but when it comes to exploitation, we have to be very, very careful. And the International Seabed Authority has a critical role to play in ensuring the sustainable exploration and exploitation of seabed beyond national jurisdiction. I guess that just about sums up my talk. Thank you so much for your patient hearing, and I look forward to questions from